Hey everybody. Today we're tackling two example problems involving confidence intervals for proportions. Here they are. I recommend pausing the video and trying these on your own before moving on. Problem 1. In a survey of 275 randomly selected American adults, 82 say that they drink coffee. Construct a level 90% confidence interval for the proportion of all American adults that drink coffee. So we have this formula for a confidence interval for a population proportion. P is representing that population proportion, the thing we're trying to estimate. P hat is the sample proportion that we get from our data. N is the sample size, and Z star is the critical Z value corresponding to the level of confidence that we have. In this case, it's 90%. Now, a confidence level of 90% is a pretty standard value, maybe not as standard as 95%, but standard enough where we can find that in a table. I can tell you it's 1.645. If you need to compute that by hand, you do that with an inverse normal CDF calculation. Plugging everything in to that formula and simplifying, we get 29.8% plus or minus 4.5%. So we have a point estimate of 29.8%, 82 divided by 175, and a margin of error of 4.5%. Problem 2. A researcher wishes to study tea drinking in America. At 95% confidence, how large a sample is needed to guarantee a margin of error of no more than 4%? So here's the formula for computing the sample size needed for a given margin of error. All the notation is exactly the same as in the first example. The issue here is that prior to a study, when we're doing our planning, we don't know P hat. We're trying to figure out our N before we get that information. And we can either estimate P hat using data from a prior study, or we can just use the most conservative value of P hat, in the sense that we should pick the value of P hat that for fixed Z star and E gives us the largest N. And that value is P hat is 1/2. And so we get this simplified version of the formula. N equals Z star squared over 4E squared. At 95% confidence, we have a Z star value of 1.960. We plug all that in. We simplify, we get N equals 600.25. But of course, we can't survey 625 people, so we're going to have to round this somehow. The rule is that you should always round sample sizes up in these situations, because if you round down, you're potentially getting a larger margin of error, and that's not allowed. So in this case, we round up. We're going to use a sample size of N equals 601.